Hello and welcome to this video. So in this video, I'll be going to the second part of ACL Principles and Configuration. In the previous ACL Principles and Configuration video, we discussed the ACL overview. In this video, we shall look at the second item, which is basic concepts and the working mechanism of ACLs. So, what are ACLs made up of exactly? How exactly do they do their job? How exactly are they able to identify traffic so that particular action based on the application can be taken on the traffic? Let us start with the basic ACL composition. So, an ACL basically consists of several permit and deny statements. We'll have statements such as permit this, deny this, deny this, permit this, and so on and so forth. It's just a set of sequential rules. And each statement is going to be a rule for the ACL. The permit or deny in each statement is the action of that rule. So every rule has an action. It can either permit or it can deny. Now, I've just presented a set of rules right here. This is the very first one. This is a second rule. This is a third rule. And other rules can be configured. There's an important aspect here. There is an implicit rule at the very end of your ACL. It's invisible. You do not configure this. The moment you create an ACL, there's going to be this implicit rule at the end of the ACL. 4,294,967,294th rule that says deny. This rule is simply denying everything else. Now, we'll come to that in a moment. For now, let us look at the composition of the ACL. So we have our first line right here, ACL number 2000. This is called the ACL number. And each ACL needs to be identified by a certain number. The ACL needs to be allocated an ACL number, and these numbers range depending on the types of the ACLs that will be described later. In this particular example, this is ACL number 2000, and this is in the range of 2000 to 2999, making it a basic ACL. Again, we shall look at that. The second part of the ACL I want to talk about is the rule ID. Now you look right here, I say this is our first rule, this is the second rule, this is the third rule, and so on and so forth. And look at the IDs. Our first rule is rule ID number 5. The second one is rule number 10. The third one is rule number 15. Why so? What's the importance? Well, I'm going to explain that in just a moment. But as I've mentioned, an ACL consists of permit and deny statements. Now, each statement is going to be a rule of an ACL, and that rule is going to be identified by a rule ID. So each ACL rule has a unique identifier, just like each ACL has an identifier, which is a number. Each of the rules in the ACL needs an identifier, and that is the rule ID. It identifies the rule. Rule IDs can be manually defined by you, the administrator, the network administrator, or they will be automatically allocated by the system. But generally, they range from 0 all the way up to this number right here, 4,294,967,294. This is the range of the ACL rule IDs. All rules are arranged in ascending order of rule ID, and in fact, they will normally be executed or matched based on the ascending order of the rule ID. Well, the third part of the ACL I want to talk about is the action. And I've already mentioned several times by now, every ACL is simply a set of sequential permit deny statements. This action is going to be a deny word or a permit word or a deny word. It's just permit or deny. Now, as I mentioned earlier, ACLs are usually used together with other technologies. And so the meanings of this word permit and this word deny will vary they are going to vary depending on the scenario. For example, when we apply an ACL to a traffic filter, in that case, which is going to be the application we shall use in this example, what we mean is that the ACL is invoked in traffic filtering. In this case, the permit action allows traffic to pass through, and the deny action rejects the traffic from passing through. Now, if on the other hand we apply the ACL to NAT, in other words, the ACL is invoked in NAT, what will happen is that the permit action will allow the traffic addresses to be translated, to be NATed, and the deny action will prevent or will not allow the addresses to be translated. It's something like that. It basically depends on where exactly you have applied the ACL. Now, the other item of the ACL I want to talk about is the matching option. ACL support various matching options. In our example here, the matching option is the source IP. You can see ACL rule number 5, source that. All right, ACL rule number 10, deny source that. The matching option is the source IP address in this example. The ACL support other matching options like layer 2 Ethernet frame header information, like source and destination MAC addresses, and even the Ethernet frame protocol type, layer 3 packet information like the destination address, the protocol type, the source address, and also layer 4 packet information like the TCP IP port number and others. But there is a bit more to this. I just mentioned the matching option. In our example here is the source IP address, and yes, you can see the source IP address, which is a host address or a network address. We can see that. But there is something else to this. There is this, and what is it? 0.00255. 0.00255. So we have an IP address, and we have something else that we call the wildcard. What is the meaning of the wildcard? Now, I'm going to talk about the meaning of the wildcard in a moment. Let me first break down the role ID. So, I mentioned earlier that every ACL rule is going to be identified by a role ID. Now, we can see in this case, we have the first rule, the second rule, the third rule. The first rule has been numbered 5, the ID is 5. The second rule is 10, the third rule is... You can see the spacing between these rules is 5, and it is called the step. So each rule in an ACL has a rule ID, and every ACL has a step configured. The step is the increment between the neighboring rule IDs. Now, the default step in the system is 5. This is the default. So if you did configure the step, it's going to be 5. But the step can be configured. Now, why do we even need this step? Why do we need to have it as 5, as 10, as 7, and so? The step facilitates rule insertion between existing rules. Let's say I wanted to add rule number 10. I would just go ahead and get into the ACL view and configure my rule, and it will be inserted right between 10 and 15 because I added rule 11. This is the importance of step. If we had these rules as rule 1, rule 2, rule 3, and later on we want to insert a rule here, we cannot do that because all the possible numbers have been used up already. So if a rule is manually added to an ACL but does not have a rule ID specified, the system will allocate that rule and ID will allocate that rule and ID that is greater than the largest rule ID in the ACL, but it is also the smallest integer multiple of the step value. That is what will happen if a new rule is added in the system. So the step can be changed. It can be configured, for example, to 2, in which case these numbers will change to 2, then 4, then 6, can be changed to 3 or 4. If it's changed to 4, then those numbers will be 4, then 8, then 12, and so on and so forth. As I've mentioned, the main importance of this step is to facilitate insertion of new rules into the already existing rules. And then what about now this that I already mentioned is called the wildcard. Now, the wildcard is a way that we facilitate matching, but how exactly does that happen? So when an IP address is matched, a 32-bit mask is followed. That 32-bit mask, this is called the wildcard. When you see it as 0, then it's 0.0.0.0. So that is 0.0.0.0, that's 0.0.0.0. But what exactly does it mean? Well, a wildcard, as you can see, is also expressed in dotted decimal notation, just like a subnet mask or like an IP address. After the value is converted to binary, in this example, if this is converted to the binary 0.0000000000000000000 all 4 times, after it is converted to binary like this is when we can attach meaning to a wildcard. Because once it's converted to binary like that, it means the 0 is for matching and the 1 is for random allocation. In other words, every 0 means that that bit must be matched exactly, and the 1 indicates that the equivalent bit does not matter. Okay, let me try to bring this closer. I'm going to give 2 examples here. Look at this wildcard and look at this wildcard right here. Now, when you look at rule number 5, it has 10.1.1.1 and the wildcard of 0.0.0.0. Now, a wildcard of 0 means that that octet is fully matched, so that one has to be 10, but this also has to be 1, and this has to be 1, and this has to be 1. What this means is that this particular rule is going to match only traffic from this particular source IP address. It is just an individual IP address. No other IP address can be matched by that rule. Now, on the contrary, let us look at this wildcard. We have 10.1.1.0 with a wildcard 0.0.0.255. Now, as I mentioned earlier, this is going to match the 10. So all traffic from 10 dot, this matches the 1 completely, dot, this matches that 1 completely, dot. But now this is a 1111111. This is 255. What that means is that the bits right here, all the 8 bits, do not matter. Whether it is 0, whether it is 1, whether it is 2, whether it is 3, whether it is 4, as long as these 3 octets are the same, that traffic is going to be matched. That is what that particular rule is trying to mean. It permits packets with the source IP address on the network segment 10.1.1.0. So the wildcard 0.0.0.1111111 and the last 8 bits being 1s indicate that the bits do not matter. Therefore, the last 8 bits can be any value. Can be any value. For instance, if you wanted to match the address 192.168.1.1 with a 24 subnet mask, this will be matched by 0.0.0.255. If it was with a 32 subnet mask, it will be matched by 0.0.0.0. That is what a wildcard mask is. But now there is more interesting idea about the wildcard mask. Can we use it to match odd IP addresses, for example, of this network segment? So the IP addresses such as 1.1, then 1.3, then 1.5, only odd IP addresses. Well, with the wildcard mask, that is possible. Let us first look at the odd IP addresses in particular, in detail, and we see what we've got. So look at this IP address 1.1 right there. This is 1.3 right there. This is 1.5. Look at them. 1.1 is 0.0000001. 1.3 is 0.0000011. All right. 1.5 is 0.0000101. You realize 1.7 is 00 all zeros and then 111. 1.9 is 0000, then 1001. Look at them. Look at all odd IP addresses. The last bit is going to be 1. It doesn't matter what these other bits are. These ones keep changing, as you can see. They keep changing, they keep changing, they keep changing depending on the number, but the last bit for odd numbers is always 1. So we can use a matching option, a matching IP of 192.168.1.1 and that wildcard mask. This wildcard means that all these are ones, they don't matter, 1, 2, 3, 4, 5, 6, 7 don't matter, but the last one matters. It has to be 1. In that way, we are able to match all IP addresses in that network segment, but that have an odd IP address. Now, there are two special wildcards. There are two special wildcards. One of the wildcards is the one that is all zeros, and the other wildcard is the one that is all 255s, all 255s. So the wildcard that is all zeros matches a host IP, that exact specified IP only. And the wildcard that is all 255s matches all IP addresses. Those are important wildcards. We have special scenarios in which we use them. So let us next talk about the classification and identification of ACLs. Now, ACLs can be classified in two different ways. We can classify them based on role definition methods. How exactly are you defining the role? Are you defining the role based on the source IP only, or a combination of source IP, destination IP, source port, destination port, protocol, and so on and so forth? Are you specifying only layer 2 header details or fields in when you're specifying your roles, or is it user defined? So you realize when we base on rule definition methods, we have a total of 5 ACL types: the basic ACL, the advanced ACL, the layer 2 ACL, the user defined ACL, and the user ACL. Now, as you can see, each of these is specially identified by a particular range. Basic ACLs range from 2000 to 2999. What this means is that when you're defining your ACLs, you don't need to say basic ACL. As long as you say it's ACL 2000, for example, it's going to be a basic ACL. 2016, it's going to be a basic ACL. 2940, it's going to be a basic ACL as long as it's in this range. On the other hand, advanced ACLs will take that range. Layer 2 ACLs will take that range. User-defined ACLs will take this range, and user ACLs will take that range. We can also classify ACLs based on the ACL identification method, where we have numbered ACLs and named ACLs. Now, you should note that when we specify a number for an ACL, we can specify a number, for a named ACL. The ACLs of different types have different number ranges, and you can also specify a name for an ACL to help you remember the ACL purpose. So a named ACL consists of both a number and a name. The name will basically facilitate your memory of the purpose of that ACL. So you can specify an ACL number when you define an ACL name as much. So if you do not specify the ACL number for a named ACL, the system is normally going to auto-generate a number and allocate a number to the named ACL. I will talk a little bit about advanced ACLs and basic ACLs, just these two. So I mentioned earlier that basic ACLs are able to match traffic only based on the source IP address. So when you look at these ACLs that are ranging from 2000 to 2999, they will match traffic only based on the IP header and not the entire IP header, but just the source IP address of the IP header. So if you have rules such as Rule 5 denies source, Rule 10 denies source, Rule 15 permits source, these are only identifying traffic based on the source IP address. Those are basic ACLs. Advanced ACLs, on the other hand, use both the IP header and the layer 4 header, TCP UDP header, to identify traffic. An advanced ACL can be matched based on the elements like the source IP address, the destination IP address, the protocol type, the TCP or UDP source and destination port numbers in an IP packet. A basic ACL actually is a subset. Many people regard it as a subset of an advanced ACL. Now, when you compare an advanced ACL to a basic ACL, clearly, I hope we can see that an advanced ACL will be more accurate and can get complex and has really flexible rules. Look at these examples. Rule 5, permit IP from here going there. You see, you can be more granular. You can specify who exactly is speaking to who. Look at this other rule. Rule 10, permit TCP source. So TCP, to traffic from this source, but not just any traffic from that source. Traffic from that source that is using TCP at layer 4. If it is headed to that destination and is headed particularly to port number 21, you can get really granular with the definition of your rule. So when all these things happen, you're at the end of the day going to apply this ACL somewhere, and the ACL is going to be matching traffic. But how exactly is this ACL going to match traffic? When traffic goes through a device on which an ACL has been applied, that device will have an ACL matching mechanism. So, of course, when we have a router, say at that point, and there is traffic traversing the router in that direction, let's say there is an ACL configured at this point of the router. So you configured something like ACL 2000 at that interface of the router, gigabit Ethernet 0/0/0. What happens when traffic hits that point? The router can see there is an ACL. So the first question is this referenced ACL existent? Does the referenced ACL exist? If the referenced ACL does not exist, then the result is going to be a negative match and we shall end. That's it. Results at the end of the day will either be a negative match or a positive match. And these are very important. You can see if the ACL does not exist, it is not a no match, it is a negative match. If the ACL exists, then the next question is, does it have rules? Now, again, if there are no rules, the ACL exists, true, but there are no rules in ACL 2000. Someone just did ACL 2000 and exited the ACL view and configured other things. They forgot to put rules. Then the ACL matching result would be a negative match again, and we shall go right to the end and move on to other tasks. Otherwise, if there are rules in the ACL, then we shall analyze the first rule based on their rule ID, the first one as based on the rule ID. And then the question is, does that traffic match the rule? If the traffic matches the rule, we look for which action is in that rule. Is it a permit action or a deny action? If it is a permit action, then the ACL matching result is permit. This is actually positive match permit. So positive match has two results: positive match permit and positive match deny. So this is positive match permit and this is positive match deny. So when the rule is a permit rule and it has been matched, the ACL matching result is a positive match with permit. If it is a deny rule, then the ACL matching result is positive match deny, and we go right to the end once we match. Notice in this that once a rule has been matched, we shall go to the end. If an ACL does not exist, we go to the end. If the ACL exists and has no rules, we go to the end. If there are rules and the first rule is matched, we shall give the result of that match and go to the end. We won't proceed to other rules. However, if the rule is not matched, we shall check other rules in the ACL. If there are no other rules, then the result is a negative match. Again, no rule has been matched. If there are other rules, we shall analyze the next rule, and in the same way, we match the rule. Is it matched? Is it permit or is it deny? And we shall get similar results until our ACL is fully matched. I want to reiterate this. The matching will stop as soon as a certain rule is matched, whether it's the first one or the 17th or the 20th, it doesn't matter. Once a rule is matched, that ACL matching will stop immediately. So ACL matching order and result. So I've already mentioned that an ACL can consist of multiple deny and permit statements. I've also mentioned that each statement describes a rule. Now, it is important to note that sometimes rules overlap or they conflict. Sometimes rules overlap or they conflict. So let's say we have rule number 5, which says permit. Permit 192.168.1.0 and this is 0.0.0.255. Now you notice that this rule permits all this traffic in that network. And then we come and say rule 10, deny. We want to deny traffic that comes from 192.168.1.14. 0.0.0.0. Look at this definition. In rule number 5, we permitted all traffic from the subnet 1.0. All of it, 1.0, 1.1, 1.2, 1.3, up to 1.255 is permitted by that rule. In rule number 10, we come and say, 1.14 needs to be denied. Now, the problem with this definition of rules is that if traffic comes from 1.14, we shall start by checking rule number 5, and that traffic will match that rule because 1.14 is in that network. So it will be permitted, and after being permitted, since a rule has been matched, we won't match any further. This rule right here will never be reached at all. So they overlap. Therefore, the ACL matching order is extremely important, that we all understand the ACL matching order. Now, our devices support 2 matching orders. We have what you call the auto order and the config order or the configuration order. We have the automatic order and the configuration order. Now, this is very, very important. In the auto order, the system will arrange rules according to precision of the rules, depth first. For example, just as a simple example to bring this point home, if you put these rules in the system will take this rule first. It will match this rule first because it is deeper, it is more specific. Its precision is high, it's specific, it looks at particular IP address. The system will start with this rule if used the auto matching order. The system will go with precision first. It's called the depth first principle. And then it matches packets against the rules in descending order of precision. Descending order of precision means those that are most precise will be matched first to prevent an overlap, such as the one I've illustrated in this example, because you really want to match the more specific rules as you move on to the more general rules. So if you have a rule which is a slash 32, match that first. A rule which specifies a slash 28, and a rule which specifies a slash 24, and a rule that specifies a slash 29, and a rule that specifies a slash 16, and it's the same network. You will start by matching this, and then you go ahead and match 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 this. You don't do the other way. This is based on precision, of course, based on the wildcard. That is what the auto matching order does, or the automatic order. Now, this is a very complicated matching order, and I can't give you details of that here. For those of you who will maybe sometime meet me in an HCIA class, we'll look at this. So, but if you're curious, you could look it up. Now, the other matching order is the configuration matching order, where the system matches packets against ACL rules in ascending order of rule ID. This is the one we are illustrating in the slide. The ACL or the system matches packets against ACL rules in the ascending order of rule ID. It will simply rearrange your rules in ascending order, rule IDs in ascending order, and start matching from top down. It's the matching order we mentioned in this course, and it's the matching order we shall mention in the labs. As a bonus, I might set up for you an automatic order in one of the labs. Now, if another rule is added, the rule that has been added is going to be put in the corresponding position, and the packets are still matched in ascending order. Now, as I've mentioned, when you talk about matching result, we have permit and deny, they will correspond to the actions depending on the application of the ACL. Let us try to analyze this ACL 2000 right here. So we can see it has rule 1, permit source 192.168.1.1, and a host wildcard specifying only that IP. Rule 2, permit source 192.168.1.2, and also specifies that just that IP. Rule 3, permit deny source 192.168.1.3, and specifies that particular IP. Rule 4 permits everything else. So let's see. What happens if traffic comes from 192.168.1.3 and reaches this device right here? What is going to happen? Well, as we said, the first rule will be matched first. There is no skipping. The ACL, the system will check ACL 2000 and match this traffic against rule number 1. And because this traffic is not in the range of specified IP address, it's going to return a negative match. Because it's a negative match, we shall go on to rule number 2 and match this source IP, all that traffic, against that ACL rule. And as you can see, it doesn't match, and so we shall have the result as a negative match. And then we shall go ahead and rule and match with rule number 3. And because this traffic is from that IP, it results into a positive match. It's a positive match. And this particular rule is a deny statement, so it's a positive match with a deny result. Now, depending on where this ACL has been applied, if it has been applied, for example, on traffic filter, then this particular packet will be blocked. It will not be allowed to go through. If it is applied to network address translation, this particular packet source IP will not be translated. If it is applied to telnet, and so on and so forth, depending on where the ACLs are applied. Again, I want to reiterate, ACL, permit, deny, do not exactly mean the traffic is going to be permitted or denied. That is going to depend on what the ACL is applied to. Has it been applied to traffic policy? Has it been applied to traffic filter or routing policy? Is it applied to NAT? Is it applied to telnet? Is it applied to what exactly has the ACL been applied to? Is it applied to a channel like IPsec, or what exactly is it applied to? Will determine the meaning of permit and the meaning of deny in the ACL. As I've mentioned, ACLs are going to be applied on device interfaces. ACLs can be applied at the ingress interface or at the egress interface. So for traffic traveling in that direction, this is ingress interface and this is egress interface. In that case, when we apply the ACL here, we are applying it in inbound direction because that's where the traffic gets into the router. That's where the ACL is. We assume the ACL is right here. So we are applying it in inbound at the point of getting into inbound direction. If we apply it here when traffic is heading that direction, we say we have applied it in the outbound direction. And so when you're using the apply rule or the apply command, you apply it to the outbound direction. So what exactly happens in inbound direction and outbound direction? Well, some interesting facts right here. Let us look at the inbound direction first of all. So we have an ACL applied at the inbound. How exactly is the router going to treat that packet, that traffic? How is it going to analyze the ACL? So first of all, when the packet hits the router, the question is the ACL applied to the interface's inbound direction. If it is not applied to the inbound direction right there, then we shall go ahead and route the packet based on the routing table. But if it is applied to the inbound direction, we shall go ahead and analyze the ACL based on the procedure we've just looked at here. We shall go ahead and match the ACL based on this procedure, and after matching the ACL, we shall get the result. If the packet has been denied, we shall drop it. If the packet has been permitted, it will now proceed to the other processing parts of the router, and subsequently the packet will be forwarded. If it is applied in the outbound direction, packet hits the router and there is an ACL applied to the outbound direction of that packet, what's going to happen? First of all, before the ACL is processed, the packet is going to be routed. So the first question is, do we have a matching route entry available? If there is no route entry available, of course we'll drop the packet. But if there is a route entry, then we shall route the packet to the outbound interface based on the routing table. And that's where we shall start analyzing the ACL. Is it applied to the interface's outbound direction? If yes, then we shall go ahead and match the ACL based on the procedure we looked at right here. And depending on whether our result is permit or deny, and also the application of the ACL, we shall go ahead and either forward the traffic or act accordingly and drop the traffic. So this, ladies and gentlemen, brings us to the end of the basic concepts and working mechanism of ACLs. The next time we meet in ACLs, I'll be showing you through a configuration example and also typical applications of ACLs. I hope this has been informative for you, and thank you for viewing.